Okay, guys, here we go. We're going to do day 5, part 2, more with confidence intervals. So really, we're just going to practice what we did the day before, and then just, try to just get really good at it. Okay. All right, so first one, we'll just do a review question. So it says the scores on mathematics college entry exams are normally distributed. So you can see I drew my bell curve with a mean of 68. So I took that information off to the side. I like to put it here. And a standard deviation of 7.2. And this is students scoring higher than one deviation above the mean will not be enrolled in a math tutoring program. So let's go ahead and draw out one deviation above the mean. So I need to do 68 plus 7.2, and I get 75.2. So they're saying that all of these kids are not going to get this tutoring. But I want to know how many of the 750 will get the tutoring. So what I'm looking for is this score and down. So let's go back to the calculator and figure out how we do that. So this is just from the other day. So I wrote the calculator steps out for you again. You go to a clean page, you go to menu, 652, and then you're going to pick your normal CDF. That's what choice number 2 will be. And remember, your lower bound is going to be a small number, right? Because I'm going from 75.2 all the way down. So you leave what the calculator has there for the small number, which is that -9e number, the scientific notation one. You leave that. You put in your upper of 75.2, you put in your mean, and you put in your 7.2. Okay, when you do that, wow, it is raining hard outside. I don't know if you guys can hear that. Okay, so if you do that, you get 0.8413, right, which is about 84%. But I want to know how many out of the 750. So you take that number on your calculator screen and you multiply by 750. And you get 631.0085, and we can see that choice 1 is the best one to use. Remember, go back to the other video where I actually hold the calculator and I show you. I wish I could do that at the same time here, but as soon as I go off this screen and go into the camera, the video stops on me, so I can't do that. Okay, we're going to skip that one, and let's look at number 2. All right, number 2, let's check out what this dot plot is that you did in 9th grade that they're giving me here. It says, if we are trying to determine the percentage of Americans who own an iPhone, we may obtain 100 sample groups, randomly chosen with 50 people in each group. So, again, if you're watching the news, this is, what Governor Cuomo's talking about all the time with them getting their samples, and they're showing you how many of the people, have been infected with the virus. And now they're doing, they're taking the samples and seeing how many people have the antibodies. So it's when you can't get a full population, you can take sample groups. All right, so these sample groups then, the average in the sample groups of how many people have the iPhone are then plotted on here. So what we see here is like the mean of means, which we talked about the other day. Now they're calling it a proportion. Well, a proportion, a percent, a probability, they're all the same thing. So the proportion of people owning an iPhone from each sample group is 19 out of 50, 21 out of 50, 32 out of 50. So they took those fractions, they turned them into decimals, and then they plotted each one of those samples. Each dot represents the proportion of people from a sample of 50 people. All right, so the first thing I want you to do is calculate the margin of error. Remember what the margin of error formula is. It's going to be twice the standard deviation. What's really nice is they give me this information. So MO is going to be 2 times the standard deviation. Okay, my cat is back again. I got to feed him before I do these videos. And then just go ahead and throw that in your calculator. So the margin of error is 0.16. Now they want me to state the 95% confidence interval. So it's the mean plus or minus two standard deviations. Now, I know we just calculated the two standard deviations, but I really, really like you still to just write it out every time. So remember, this is my mo. When you make this calculation, 0.51 plus twice the standard deviation and 0.51 minus the standard deviation, we're left with 0.35 to 0.67. Okay, so that's going to be my 95% confidence interval. So what does that mean? It means that we think that in America, the true real amount of people that have a cell phone is between 35%, or have an iPhone, I think, is that what they were saying here? Yeah, iPhone, is between 35% and 67%. So that's why if you're watching the news and they're talking about what they think the real percent of, he's always talking about New York State, either are testing positive or have had the virus. They're basing it off of these samples that they do, and then they infer from the samples. They try to come up with what they think the real amount is, and that's what this is. So it's kind of cool that we're doing this. If anything could be cool, I guess, during this time. All right, and now this question, it says, would 0.685 be a usual mean? Well, it's going to be usual if it falls within the 95% confidence interval. It'll be unusual if it falls outside of it. So would this one be usual? So we have 0.685. So this one falls on the outskirts, right? So this guy would be unusual, because it doesn't fall inside there. Okay, and you could just write that. Okay, number 3. Okay, let's check out this one. So look, they love to make like these big long word problems, but you can see what I did at the bottom there. As soon as you see that 95% confidence interval, you're going to write mean plus or minus 2 standard deviations down at the bottom here, like every time. Now, you do have to just read a little tiny bit up there, and I would circle this because this information is always going to be important. Okay, so this is like the iPhones, except in their sample groups, they're looking at who likes like this new soda they came up with. Okay, so it says Stevens Beverage Company is considering whether to produce a new brand of cola. The company will launch the product if at least 25% of cola drinkers will buy the product. 50 cola drinkers are randomly selected to take a blind taste test of products A, B, and the new product. 9 out of 50 participants preferred Stevens' new cola compared to A and B products. The company will devise a simulation based on requirements that 25% of cola drinkers will buy the product. So instead of going out and doing all these little random experiments with people, they're having a computer take this one sample and come up with what's called a simulation, where the computer will come up with the supposed data. It says each dot in the graph shown below represents the proportion of people. Remember, proportion, percent, probability. That preferred Stevens' new product, each of a sample size of 50, and then simulated 100 times. So the computer just did 100 samples. Okay, so I took 9 out of 50, and I just changed it over to 0.18 because I noticed that all of these are in decimal. So let's just keep that information for a second and go down below. Okay, assume the set of data is approximately normal, right? So that's our bell curve. And the company wants to be 95% confident of its results. So that's why I'm going to do my mean plus or minus 2 standard deviations. Does the sample proportion, so that 9 out of 50 that we have up top, we want to see if that falls within the margin of error. Okay, so let's see. So we got our mean plus or minus 2 standard deviations. So we wind up with 0.35 to 0.662. And then his was, what was our decimal value up there? 0.18. Okay, so let's see. So does 0.18 fall inside the confidence interval? So our answer is no. 0.18 does not fall within the confidence interval. Alrighty. Okay, next. And you can see these all look about the same. And, I highlighted again the 95% confidence interval, and this data is also going to be super important. Okay, let's check it out. It says some smartphone applications contain in-app purchases which allow users to purchase special content within the application. A random sample of 140 users found that 35% made in-app purchases. A simulation was conducted with 200 samples of 140 users, assuming 35% of the samples make in-app purchases. Okay, and then, so this is a dot plot again, and again, a simulation was made, so like the computer did it. But what's nice about these questions is they're always pretty much asking the same thing. So it says, considering the 95%, the middle 95% of the data, determine the margin of error. So they want me to find the margin of error to the nearest hundredth. So remember, margin of error is just twice the standard deviation. And they want to go to the nearest hundredth. And that's it. So it's pretty good stuff here that you guys can do. All right, number 5, same idea again, just different story. It says a radio station claims to its advertisers that the mean number of minutes commuters listen to a station is 30. A station conducted a survey of 500 of their listeners who commute, and the sample statistics were below. So we have our mean, and then SX, that's our sample standard deviation. Now it says here, a simulation was run 1,000 times based on the results of the survey. So these are the results that we got. So this is the information that we're going to use now because they took that one sample of above and created this simulation. It says, based on the simulation results, is the claim that commuters listen to the station on average 30 minutes plausible? Explain your response, including an interval containing the 95% of the data. Okay, so we'll make our little guy again. So our mean plus or minus 2 standard deviations, 27.233 to 30.969. And now they're saying to the nearest hundredth, so 27.23 to 30.97. And then we want to know, does that fall inside the 95% confidence interval? And the 30 minutes does fall inside there. So yes, because it falls in 95% confidence interval. All right, so you can see how so many of these questions are just the same. So that's about it. I think we'll skip the stuff on the back. I don't want to give you guys too much to do. That's just review anyway. All right, so give it a shot. Bye.